Electronic symbols are standardized visual representations used to depict components, connections, and functions in electrical and electronic circuits. They serve as a universal language in engineering, allowing professionals to communicate complex designs efficiently. For instance, resistors are represented by zigzag lines or rectangles, while capacitors appear as two parallel lines, one sometimes curved. Diodes, including bridge rectifiers, are shown using triangles pointing to a line, indicating the direction of current flow. Inductors are drawn as coiled loops, and transformers as two sets of such loops separated by lines. Sources of power, such as batteries, are depicted as alternating long and short lines. Ground symbols indicate the reference point for a circuit, and switches are illustrated with breakable lines to show their open or closed states. More complex symbols, like logic gates or flip-flops, represent digital operations or memory storage in circuits. These symbols simplify intricate circuits, enabling clearer documentation and understanding of systems ranging from simple devices to advanced electronics. Electronic symbols represent components and connections in a circuit, providing a visual shorthand to describe the design. Here's a brief overview of the items you mentioned. Traces represent conductive paths on a circuit board, often made of copper. They connect different components, allowing electrical signals to flow. Traces are essential for creating functional circuits. Grounds indicate the reference point in a circuit and the return path for current. They are represented as horizontal lines or triangular spikes. Grounding ensures circuit stability and safety. Sources provide power to the circuit, such as voltage or current sources. Commonly symbolized as batteries or circles, they initiate electrical flow. They can be AC or DC sources. Resistors limit current flow and control voltage within circuits. Depicted as zigzag lines or rectangles in some regions, they are key to managing electrical energy. They prevent damage to sensitive components. Capacitors temporarily store and release electrical energy in a circuit. Illustrated as two parallel lines or one curved line, they regulate voltage and smooth fluctuations. Capacitors are vital for timing and filtering. Diodes allow current to flow in one direction, blocking it in the reverse. Represented as a triangle pointing to a line, they protect circuits and enable rectification. LEDs are a common type of diode. Bridge rectifiers consist of 4 diodes arranged to convert AC to DC. The symbol connects the diodes in a diamond pattern. These are crucial in power supply circuits. Inductors store energy in a magnetic field when current flows through them. Depicted as coiled loops, they oppose changes in current. Inductors are commonly used in filters and transformers. Transformers transfer energy between circuits using magnetic induction. Shown as 2 coils separated by lines, they adjust voltage levels. Transformers are vital in power distribution systems. Unipolar transistors, voltage-controlled components like FETs, used for switching or amplifying. Their symbols include gate, source, and drain terminals. They are efficient for high-speed operations. Bipolar transistors, current-controlled devices with emitter, base, and collector terminals. Used for amplification and switching, they are illustrated with arrows indicating current flow. Widely used in analog circuits. Vacuum tubes, legacy components that control electron flow in a vacuum. Represented as circles with internal electrodes, they were used before transistors. Still found in some audio and high-frequency systems. Switches control the flow of electricity by opening or closing circuits. Shown with breakable lines, they can be manual or automatic. Switches are integral for user control in devices. Relays, electrically operated switches controlled by a magnetic field. Their symbols include a coil and movable contacts. Relays are used for isolating and controlling high-power circuits. Lamps convert electrical energy into light, symbolized by a circle with a filament. Found in indicators or lighting systems, they come in various types. Essential for visual cues in circuits. Current limiters prevent excessive current flow to protect components. Often depicted as resistors with added details. They ensure circuit safety and prevent overheating. Electroacoustic devices include microphones and speakers for sound conversion. Symbols vary but often resemble diaphragms or cones. They bridge electrical signals and sound waves. Antennas transmit or receive electromagnetic signals, often depicted with radial lines or spikes. Used in communication systems, they link circuits to the outside world. Antennas vary widely in design. Connectors represent plugs, jacks, or pins that join circuits or devices. Shown with simplified shapes like rectangles or lines. They allow easy assembly and reconfiguration of systems. Logic gates perform basic digital operations such as AND, OR, and NOT. Represented with unique shapes for each function, they are building blocks of digital circuits. Logic gates process binary data. Flip-flops, fundamental memory elements in digital electronics. Their symbols are rectangles with labeled inputs and outputs. Flip-flops store and toggle binary information. Each symbol has its unique functionality, and these visuals allow for a compact and clear way to communicate complex electronic circuits. I hope this gives you a strong starting point. Let me know if you'd like to dive deeper into any of these.